Yes, hello everyone. Yes, Kanchan, hello. Yeah, yes, good evening to all of you. Yeah, in this video we will be solving first law of thermodynamics numericals and thermochemistry numericals. And before we solve those numericals, I will be like giving you a brief idea about this chapter, and whoever are new to these classes, they can like understand how depth we understand each and everything. Okay, how much depth we generally go whenever we understand a particular topic. Yes, Akash, Fulwani, Tapash, Kundan, Patatri. Hello everyone. Yes, it will be continued. Tapash, it will be continued. This series will be continued until all the chapters are completed. Okay. And more or less every alternative day I will be taking classes. Like today I am completing this first law and thermodynamics and thermochemistry. Tomorrow I will be completing the second law, because thermodynamics is a very first chapter. So I don't want to skip any questions. So in this like 2 hours or 2.5 hours live classes, I will be finishing only this first law and the thermochemistry. Fine. And in next classes we will be following the other chapters as well. Yes, Shama, good evening. So did you get any help in the from the last classes on gaseous state? Because I considered and I got one thing, that most of you are doing mistakes in the units. In physical chemistry numericals, you are doing mistakes in the units. So did you watch that video, and did you correct your like whatever fault you had, did you correct those? Yes, Tobai, good evening. Did you correct those? Because you, whenever you are solving questions, like you are every questions you are doing some very small silly mistakes. Yes, so please make them correct. If you don't make them correct right now, you will be doing the same mistakes in IIT JAM examination. All the questions that you will be getting like are very close, very simple questions. Okay, and whatever I taught you already, everything you will be getting from those. Fine. And one important thing is that as I like teach you from like initial phase to depth phase, so everything you have to revise. You don't skip anything. Maybe whenever you are revising, you are skipping the derivation, a complete derivation, 2 page 5 page derivation, whatever I have done, you can skip that derivation, but you can't skip all those things, all like everything. Like you are reading only the, like you are looking at the slides and going here and there, here and there, here and there. No, you shouldn't do that. You have to understand each and every concept. Okay, so fine, so let's start then. So first I will be taking 30 minutes maximum to revise this whole thermodynamics chapter, because I am not going to tell you why this is happening, why that is happening. I am going to tell you this, you have to remember this, you shouldn't, you can skip. I will be telling you that one. Yes, and along with that I will be telling you that where you shouldn't do any mistake, or where you can do mistake but you have to avoid that, and how you can avoid that. Okay, then we'll be moving forward to numericals. Like 15 to 20 numericals are there, 20 numericals, 20 different kinds of numericals are there. So first understand these numericals, then I have given you a lot of numericals in my study materials, right? I have given you, provided you the like numericals, so you can just go through all those numericals. Your thermodynamics will be completed, and I can promise you that you will be getting questions along with the formulas that I have used to solve those numericals. Okay, that is the thing, because if you check last 10 years question papers, you can also get the same formulas are used to solve numericals. So why the next year questions like you can't solve with those formulas? Definitely. And whatever I taught you, these are enough for graduation level thermodynamics, not only JAM, graduation level thermodynamics. Okay, yeah, definitely. So without further time wasting, let's get started. So first of all, if you want to like practice a lot of questions, start now, from now, and stay till the last. If you are like thinking, okay, I'm just going because I can't understand anything, whenever I will be revising all those things, maybe you are not understanding something, that means you have some lack in your understanding of thermodynamics. That means that doesn't mean that, like, because this video is not right, I am not teaching thermodynamics, I am just revising thermodynamics for like all of you. and all these things, whatever you can see over here, all these things are taught in the benzene batch. Great. So without further time wasting, I am starting then. Okay. So as I told you, what is thermodynamics? So in this thermodynamics chapter, we will be dealing with thermo and dynamics. Like thermo means heat, dynamics means movement, and this movement of heat will give you work. Okay, and this work is one form of energy, heat is another form of energy. That means whenever you are converting one form of energy to another form of energy, that is the study of thermodynamics simply. And in case of chemical thermodynamics, we will be discussing about chemical systems. Chemical system means chemical reactions, okay, or where chemical change is happening. These kind of systems we will be studying in chemical thermodynamics. So according to your JAM syllabus, you have chemical thermodynamics, not only thermodynamics. Thermodynamics is used in physics, chemistry, geology, in like astronomy, astrophysics. A lot of version of are there, but especially here we will be talking about chemical thermodynamics. Okay, and in chemical thermodynamics also we will be talking about equilibrium thermodynamics. We don't talk about non-equilibrium thermodynamics. This is not in your syllabus for the time being. So we will be talking about equilibrium thermodynamics, and from equilibrium thermodynamics we only discuss the classical equilibrium thermodynamics. We don't discuss statistical thermodynamics in this chapter. Okay, that means only macroscopic properties will be there: pressure, volume, temperature, number of mole, and ... Got it? So only classical thermodynamics, not the statistical thermodynamics. Great. Next, in this case, in the thermodynamics chapter, we will be dealing with zeroth law, first law, second law, third law. So forget about third law, it's not important, even it's not in your JAM syllabus. And before I go through all these laws, I should tell you that all these laws are empirical. All these laws are made by human experience from the nature. Okay, and here there is no experiment that is required to understand this law. Okay, all these laws are based upon the human experience, that what we are experiencing from the nature. Based upon that we made this law. Scientists made this law, all these laws of thermodynamics. Perfect. Then first, what about zeroth law? Instantly, I am just giving you quick revision. Zeroth law says I will be discussing this zeroth law, first law, second law, third law in great detail. But for the timing, what is zeroth law? Zeroth law is nothing but transmission of heat. That means if you have higher temperature body, if you have lower temperature body, zeroth law says that from higher temperature body it will go to the lower temperature body. Simple. It's a very simple concept. Yes, this is zeroth law. What about first law? First law talks about conservation of energy. That means heat can convert into work, and work can convert into heat. Total energy of the universe is constant. Okay, fine. Then second law says that how the natural processes goes, the natural processes is going to this direction or this direction, in which direction. So as we are understanding chemical thermodynamics, so suppose I am doing a reaction A plus B to C, so whether the reaction is going to this direction or this direction, this kind of thing the second law of thermodynamics will decide. Okay, so it decides the direction of the occurrence of the natural process. And what about third law? Third law means ices. You know this already. I told you a story regarding that. Fine. So forget about that. Now coming to the most important system. That is, in the first law of thermodynamics, what is system, surrounding, universe, boundary? System means this is your system. Boundary means this skin. Like if this system is you, your body skin will be your boundary. And except this boundary, whatever things are present, like over here, that is called surrounding, right? And the system plus surrounding, that makes total universe. Okay, so if we are considering Earth is a system, so Earth plus the whole surrounding, that means the whole universe, that will make total universe, right? So system it is system, it is surrounding, so system plus surrounding makes total universe. So easy. Boundary is three types: dithermal impermeable boundary, permeable boundary, adiabatic boundary. Yes, so dithermal or impermeable, that means from this boundary only energy can transfer, matter cannot transfer. Okay, from this boundary only nothing can transfer, neither matter not energy, like thermoflask is one kind of example. Then adiabatic boundary, both can Okay, so adiabatic boundary means neither energy, okay, I'm sorry, I have told you something else. Permeable boundary means like, yeah, or both of these, both matter and like energy, both can transfer, okay. And adiabatic boundary means like neither energy nor matter can pass, can cross this boundary, okay. So this is my boundary, and this boundary can be three types, okay. One is permeable, impermeable and adiabatic. Got it? Then coming to systems. So depending upon boundary, systems are three types. One is closed system, open system and isolated system. Closed system belongs to impermeable boundary, open system belongs to permeable boundary, adiabatic system belongs to isolated. Adiabatic system is called isolated, that is means adiabatic boundary. Simple, so I am not discussing this, okay. And if I consider closed system, that is called to understand closed system, we need to understand thermodynamics for closed system. To understand open system, we will be talking about thermodynamics for open system. To understand this isolated system, we generally talk about thermodynamics for isolated system. Most of the cases we understand this thermodynamics for open system, closed system, and sometimes it's open system. And this the study of thermodynamics of isolated system is generally studied in this thermodynamics for closed system. So like we don't discuss this one like individually, we discuss this in this thermodynamics for closed system. But closed system and open system, these we need to discuss in a different way. Got it? Perfect. Then what are properties of system? There are two properties, extensive properties, intensive properties. So what about extensive properties? Extensive properties are like, suppose you have a big system and you are cutting this system into different parts. So if the properties of that big system is changing whenever you are cutting them, so if the properties which are changing, so this system and this system, if you are comparing some properties, if the property is changing, then we will be calling those are my extensive property. If those properties are not changing, intensive property. Examples, a lot of examples are given, so I am not going through all those examples. You have to revise all those things. Great. Then the most important thing is that extensive property dependent upon mass, intensive property is not dependent upon mass. Then like in case of like yes, extensive property, what happens? If you add two extensive property, you get one extensive property. If you take ratio of two extensive property, you get intensive property, right? Similarly, addition and division, both of these like addition and division between two intensive property will always give you intensive property. Perfect. Now come back. States of thermodynamic system. What about states? So there are different kinds of states. Equilibrium states, steady states. Equilibrium state means from the like microscopic level, it is not like the reaction is still happening. If I tell you about the reaction from the microscopic level, the reaction is still happening, but from the macroscopic level, it is looking like it is stopped. And what about steady state? Steady state is nothing but like from the microscopic and macroscopic level, from both of these level, your state is steady, stopped. Okay, so I have given you these kinds of example like that. Fine. Then coming to the functions and variables. What about functions? There are two kinds of functions, state functions, path functions. State functions depends upon only state, path function depends upon how you are changing, how you are going from initial state to final state. Got it? This is about path function. State function examples means all thermodynamic functions are state functions. Path functions, two famous one are work and heat. Okay. Then state functions single valued and continuous, path functions not single valued and discontinuous. And state, this is very important. State function generally follows this like this differential. Okay, if you do integration, you will be getting, if you do definite integral, you will be getting this kind of values. But in case of path function, you cannot do definite integral. So if you are using integration, then also you will be getting only z. Okay, like this. You are doing integration, there will be nothing like initial final state. You will only q, you will be getting, only w will be getting. Okay, and how you would represent that? You would represent that in this way: d cut q, d cut q, d cut w. So d cut. Okay, d cut. Remember d cut in this way. Perfect. Then cyclic integral becomes 0 for state function, and cyclic integral is not equal to 0 for path function. Then what about this? This condition is one of the most famous example, that condition, that is Euler's condition of exactness. Perfect. And then this is not the Euler, this is like state function generally follows this Euler condition of exactness. Path function doesn't follow the Euler condition of exactness. Now if I want to show you like some mathematical functions, how they works, that is about y equals to fx, and if you do the dy, you will be getting f prime x. You know this. But if y is dependent upon x and z, then how would you represent dy? So dy means total change of y, that you can represent like y is dependent upon x and z. That is the meaning of this function, right? So y is dependent upon x and z. So if you change y, how x and z will change, that you represent in this way. I hope you got this thing. How you should write, I told you the shortcut. Okay, these two, yeah, no, you know it. Perfect. Then P for pressure. Okay, so now let's have a look at different kinds of functions. Like I am considering pressure for ideal gas is a state function. You have to prove it. Or suppose in your examination, any kind of function they have given to you, so you know how to prove that whether it is state function or it is path function. You know how to do this. That's why I told you like from the beginning. So guys, please do comment. Do you know how to do this? How to solve this? That how would you change your function? Like how would you check that whether it is your state function or it is your path function? Can you do this using Euler's condition of exactness? I am asking to the benzene batch students. Yes, good, perfect. So any function I can give you, and you can easily check whether it is state function or path function by using by getting, suppose P for ideal gas. What you need to do, you just need to get that P is a function of two other functions, like here T and V, that you are getting from this expression, right? And then you need to check this condition whether it is following or not. So you did that, and you did that. These two are same. That means it is your state function. So pressure for ideal gas is your state function. Good, very good. Yes, good. Next, what about work? And work is a path function. I have shown you a lot of long method like that, and finally we calculated that yes, work is not state function, work is path function. I told you. So I am not showing you how you can do this right now. You can solve it, I know this. Okay, perfect. So work is the path function. Then coming back, what about Q? Why Q is a path function? That I have also shown you. I had also shown you why Q, heat, is a path function, because initially I gave you example and told you W and Q, these are like path function. But why they are path function? That I have shown you from mathematical point of view. Okay, by using thermodynamic laws. Great. Let's move forward. Okay, so even I have given you some homework and asked you like what about these functions? I told you that check pressure for real gas is state function or path function. Did you check? So please solve these mathematics. I don't know whether you have submitted or not. Actually I forgot it. I took classes a long time ago, so I forgot that one. So yes, and also do this, that whether if I consider a gas that is following this expression, so check whether from this expression P is a state function or path function. Okay, please solve these two. That will like boost your confidence that yes, if I give you any function, then like you can easily calculate that. If you can't solve that, please ask me in the group. But yes, please try it and solve it and send it by tonight. Please do it. Then what about cyclic rule? There is a very simple method to remember the cyclic rule. Suppose when we like represent cyclic rule, or when we apply cyclic rule. Cyclic rule is applied when there are three mutually dependent functions or mutually dependent variables like x, y, z. That means if you change x, y and z will change. If you change y, z and x will change. If you change z, y and x will change. That means these are three mutually dependent functions. Perfect. That means x is a function of these. So you can take any one of these. And you can show your cyclic rule. How can you do that? So I have shown you. I have derived this. How can you show your cyclic rule? And finally, I have told you what about the shortcut. Did you remember the shortcut? Please can you write in the comment box. Did you remember the shortcut, or should I repeat once again? Anybody, please do comment. Did you remember, or should I tell you once again? What about cyclic rule? Did you remember, or should I tell you once again? Please, if you forgot, then just tell me. I will be like doing this once again. Okay, perfect. Yeah, good. Yeah, good. Awesome. Perfect. Let's move forward. Then, what is the significance of cyclic rule? That I told you already, that this is my alpha, that is called coefficient of thermal expansion. This is called beta, that is called compressibility. Yeah. And you know these one, and you have to remember these two one. Please, you have to remember these two formulas. Okay, you have to remember. You cannot skip it. You cannot skip it. Okay, you shouldn't skip these two. Remember these two formulas. Maybe in IIT JAM examination somehow it is coming. Okay, and by applying this cyclic rule you can prove this expression. That's the thing. By applying this cyclic rule you can prove this expression. And don't think what is the significance of this expression. And I showed you the significance of this expression. I have shown you whenever I was teaching you entropy. Remember, whenever I was teaching you entropy, I used this expression. So sometimes like they can ask which of the following equation is correct in the MCQ question, and you have one of these option. You have this option, right? So if you forget, you can derive it. Or I will be suggesting you that try to remember this one, or by practicing. Practice a lot of times, you can remember this one generally. Okay, next, thermodynamic processes. There are different kinds of thermodynamic processes. Okay, processes means you are in state 1, you want to go to state 1 to state 2. So what will be the thermodynamic processes? What kind of processes you can like follow to go from state 1 to state 2? Yeah, so first of all, isothermal. Isothermal means thermal. Temperature remains constant, dT 0 or delta T 0. Isobaric, pressure equals to 0, dP, change of pressure equals to 0, pressure not equal to 0. Remember, change of pressure equals to 0. That means dP 0 or delta P equals to 0. Yeah. Similarly, isochoric process, change of volume 0. Adiabatic process, change of heat 0, not heat 0, change of heat 0. Polytropic process, dCp, Cp, change of Cp and change of Cv, like heat capacity. This is 0. Cyclic process, all thermodynamic state functions are 0. All thermodynamic state functions are 0. Fine. Quasi-static process. Quasi-static process means the process that happens very slowly and a lot of slow step will be there and it looks like the process is static because very small steps generally present, and because of that it looks like the system is not, there is no process happening. It is looking like static process, but very slow steps are there in case of quasi-static process. And if you extend this quasi-static process, that you will be getting reversible process, right? And what about reversible process? Simple, very slow process, infinitesimal steps are involved. Okay, infinitesimal step mean very small step. Okay, very small step, and infinite number of very small steps will be there to go from state 1 to state 2. Then third of all, what will happen? Like in case of reversible process, why it is reversible? So you can go from here to there, you can come back initial state. Okay, that means the steps are too small so that you can go from here to there easily, and you after like initial state to final state, and after the next step from final to you can easily come back to the initial state. That is very important. You can come back to in the initial state. Okay, that is your reversible steps. Okay, and I have shown you how it is possible. Then come back, equilibrium. So equilibrium will be maintained in every step. Perfect. Okay, and as I told you that one state can return to the previous state again itself or by slight variation of driving force. Yeah, that you understood. Then irreversible process. Irreversible process is very first process, do not maintain equilibrium, and if you go from here to there, you cannot come back from here to there once again. You cannot come back. Okay, you cannot come back. Perfect, you cannot come back. Okay, so I am getting one question that is about chemical, like that is about like chemical kinetics. Interesting question. So Kundan is asking, okay. Kundan is saying reversible steps are very slow step. Okay, reversible steps are very slow steps. So look at this, Kundan. This equilibrium is maintained where? Suppose you have reactant A and you are going to reactant B. So A to B, these, I am not talking about this equilibrium. Okay, I am not talking about this equilibrium. Okay, I am not talking about this equilibrium. I am telling you so if I am going from step 1 to step 2, in case of reversible process, you cannot come from here to there. B to A you cannot come directly. From B to A you cannot come directly. Reversible process means, as I told you, from state 1 you are going to state 2, and these you are changing your pressure slightly, suppose. So from this state to this state, this will be a reversible one. These two will be reversible. These two will be reversible. Not like these two I am saying. Because in case of chemical reaction, we tell reversible change means reactant product. So reactant to product is formation is possible, product to reactant is possible. But here we are not talking about that. We are talking about reversible means one step, this one, this one, this one, this one, this one, this one. So you can come back from here to next stage to previous step, next state to previous state. You can come back. You cannot come back from here to there directly. If you can come back from here to there directly, then it is not just like a reversible one, because these initial state to final state, if you want to go, you need to go through infinite number of steps. Okay, infinite number of steps, and these infinite number of steps, like step 1, 2, 3, 4, 5, 6, these 1, 2 will be in equilibrium, these 2 will be in equilibrium, these 2 will be in equilibrium. So it will take, suppose, infinite number of time, infinite amount of time it will take to go from reactant to product. And that reversible means it is for reactant A and product B. We are talking about reactant to product conversion, product to reactant conversion. Clear? Another thing, difference between quasi-static and reversible process. Great question. So what is the difference between quasi-static and reversible process? Basically, reversible process can be called as final quasi-static process, like that. Okay. So you cannot differentiate these two basically, but yeah, more or less they are like similar for the time being. Don't go into that much depth, like what is the difference between quasi-static reversible process. These are defining like very slow process, and reversible process is more like accurate, and those we are defining in this manner. That's the thing. Yeah. Then come back. Reversible process and irreversible and irreversible process. So I told you about all these things about reversible and irreversible, so I am not differentiating them once again. Perfect. Come back. Zeroth law of thermodynamics. If A is in thermal equilibrium with B and A is in thermal equilibrium with C, then B and C will be in thermal equilibrium. That is the concept. Yeah. Then work. A lot of works are there. So remember this formula, you have to remember. Surface work, gamma delta A, surface tension multiplied by increase of surface area. Electrical work, Q into V or NFE, you know this one from electrochemistry, right? Then come back, gravitational, MGH, mechanical, FDX, and for PV work will be minus P external dV. Yes, perfect. Then I have derived how you are getting this minus P external dV. Forget about derivation, don't need to remember derivation. Then come back. Yes, convention. This convention is very important. If you are doing work on the system, that will be positive work, or you are adding heat to the system, that is positive. But if system is doing work, that means work done by system, that will be negative. Yeah. So this is the IUPAC rule that you need to remember. You don't need to remember non-IUPAC rule. Forget about this rule. Non-IUPAC rule generally used in physics, not in chemistry. So only remember the IUPAC rule. Perfect. Next. So work done in different processes. So one is isochoric process, work done 0. I am talking about PV work done. Okay. Isobaric process, isobaric pressure constant. So minus P external dV. That is about this. Minus P external V2 minus V1. Yeah, I have shown you how you are getting this. Remember this expression, or if you can't remember this expression or remember this expression, do one thing, only remember P external minus P external dV. So isochoric means dV 0, so work done will be 0. Isobaric means this is constant, so only dV means doing integration 1 to 2, you will be getting V2 minus V1. So only remember the basic equation, you can easily do integration and get your expression, right? So that is the shortcut method. I don't remember, I just know the basic relation, then I derive it. It takes only 30 seconds that you can do it. For irreversible process, what is the work done? For irreversible process, for reversible process. Reversible process means minus dP, minus dP, minus dP, all these things are there. That means infinite times of pressure will decrease and system will go from state 1 to state 2. So as it is happening, so I told you, internal pressure will be equal to external pressure, because in every step the system will be in equilibrium. Equilibrium means what? These and these both are equal, that's why in equilibrium. Got it? So final expression you will be getting by doing these things, and finally this one. And remember this expression. Only remember this expression. Okay? Remember this expression. So I am getting one comment, sir jam ke liye drop kar lu. Yes, you can. If you are thinking that you can you cannot appear in this year, you can take a drop. Yeah, definitely. Moving forward. Yes, Praveen. Moving forward. So remember this expression only. For reversible work, remember only this expression, only this expression. For ideal gas, you know the p value, just put it p value from ideal gas, you will be getting for expression for ideal gas. This one, okay, I mean this one, yes, for ideal gas. For real gas, how can you do that? It is your real gas, so calculate p value, put it over there, do integration, you will be getting real gas. You don't need to like remember all this expression, just remember the basic one. You will just put the p value, do the integration. Perfect, got it? Please, Benjamin best student, please tell me, got it, yes or no? Got this, can you do this, yes or no? Please tell me. Are you remembering in this way, or like you are doing rectification? Then coming back, so if I tell you, okay, if a gas that is following this expression, what will be the expression, what will be like the changes, what will be the work done for that case, what will be the work done for the case? So you can know, you just need to calculate p value and you will be getting this. So I told you solve it, but I think didn't you you didn't solve it. I think can you tell me, did you solve it, whether you are getting this one or not? Did you solve it? How many of you have solved it? Okay, yes, how many of you that check that whether you are getting the same expression or not? How many of you? Okay, Fulvani, you solved it. Anybody else? Please solve it. Whenever I am giving you some homework, there is some meaning of giving that. Okay, Shiny, good. Okay, Arnab, very good. Akash, Shomo, good. So please solve it. Whenever I am giving you, that means that is for practice. It will take only like 2 minutes to solve. 2 to 3 minutes. Yeah, Kanchan, good. Let's move forward. What about for like any other gases? Okay, I am giving you another one. Like this gas, calculate P and solve it. Don't think these are meaningless. No, these are not meaningless. This will like increase your like confidence that okay, whatever expression they can give you, I can solve it easily. Don't think I'll be doing in the examination directly. You can't do that. Your pen will not move in your examination hall. Okay, this is your like reversible in this way. Please solve it and send it. Then or check it. Just check it. Don't need to send. Just check it. I have given you the answers. Check it. Then work done in irreversible process, not reversible now, irreversible process. Irreversible means sudden change. Only 1 or 2 steps may be required for this, to go from state 1 to state 2. And what is the final expression? Minus P external V2 minus V1. So remember only this one, and then apply for ideal gas. So for ideal gas, what will be happening? P V2 V1. Okay, V2 V1. Put the value of V2 V1 at constant temperature. If you are putting V2 V1 at constant temperature, you will be getting this kind of expression. And here one thing you need to remember: whenever we are talking about P external, please do remember, whenever we are talking about P external, maybe in your examination question paper, P external is not there, but final pressure is there. So that means final pressure is actually your external pressure. Why is that? Simple, because you are like final pressure means what? At last, what will be your pressure? At last, that means whenever the system is in equilibrium once again, at last, then what is the pressure? So at last, if your system is in equilibrium, that means it is equilibrium with what? The external pressure and the internal pressure. That means what? Both of them are equal. That means your final pressure is actually your external pressure. Please do it. So I can write this like P external in this way. Okay, so if you put P external equals to P2 and cross multiply this, then it is this. But remember basic expression. Okay, remember this basic expression. So if you don't know V2 V1, so apply this concept for ideal gas. You can calculate V2 V1 and you can put it easily. Yeah, great. Real gas, you can do this. Okay, for real gas I have calculated the same thing. Okay, now for any other gas, like I am considering this P, the gas which is following this expression, you have calculated the same thing. In this way you can calculate this. Okay, now work done in cyclic process, right? Cyclic process. So there are two kinds of cyclic process. One is reversible cyclic process, another is irreversible cyclic process. Cyclic process means what? P1 V1 T at constant temperature. I am going to another one like P2 V2 T and again coming back to the P1 V1 T. I am completing a full cycle. Okay, I am completing a full cycle. Yeah, this is called cyclic process. So first of all, reversible cyclic process. Reversible cyclic process means the process expansion and compression. That means suppose I have this piston. Okay, I have this piston. I am doing expansion, like the volume is increasing. Then I am again doing compression, so that the volume is decreasing. That means I am coming from like lower volume to higher volume and again higher volume to again lower volume. This is the complete process, cyclic process. I am getting one comment. When P external is not equal to P2, Every time P external should be equal to P2. Yes, according to your point of view, every time P external equals to P2. Until and unless they have mentioned that P external is this, final pressure is this. But it doesn't happen. Most of the cases these two becomes equal. Okay? Good question. So reversible cyclic process, you don't need to know, you don't need to remember anything from here. You just need to know the final expression. For reversible cyclic process, work done is 0. Yeah. But for irreversible cyclic process, that means for in nature what is happening? Irreversible process means the natural process. In natural irreversible process, that means suppose you are going from Delhi to Mumbai and again Mumbai to Kolkata and Kolkata to again Delhi to Mumbai, Mumbai to Kolkata, Kolkata to Delhi. So that means your natural process. In this process, your cyclic integral cannot be 0. That will be positive. Your cyclic integral will be positive. So you will be thinking, okay, I am going to Delhi, Delhi to Mumbai, then Mumbai to Kolkata, again Kolkata to Delhi. So my total work done should be 0 because it is a cyclic process. But cyclic process, but no, because it is a natural process and you know all natural processes are irreversible, not reversible. So reversible means 100% perfect system. So nature is not perfect. Complete perfection in nature is impossible, right? So your work done, your cyclic, after this cyclic process, that means after irreversible cyclic process, total work done will be positive work done. That means positive work done means what? Surrounding will do some work on you. You are not doing any work. So you are going by losing your own energy, but surrounding overall surrounding is doing work on you. Not you are doing more work. It's interesting, right? Whatever it is, surrounding is doing more work than the system. Then what about work done in evaporation of liquid? Just remember the formula, just final one, right? You are getting this expression and finally you are considering your vapor will behave ideally. So remember this expression, W will be equals to minus nRT. And guys, one thing that you need to remember, that is about whenever you are solving numericals, please check it that what is being asked in the question, work done by the system or work done on the system. If work done by the system, that means you have to calculate minus W and that value maybe will be positive. Or if work done on the system, that means you have to calculate plus W. That means that value can be positive or negative based upon the situation. So put your answer. So you will be doing mistake whenever in minus or plus. I know this. That's why I am telling you. Please check whether what they are asking in the question paper. Work done by the system or work done on the system. If system is doing work, you have to put a negative sign. You have to calculate minus W value. Whatever it is, positive, negative, I don't know. If system is doing work, if you are doing work on the system, that is positive W. Clear? Don't do mistake. You will be doing mistake over here. You can write this point in your mistake books. Perfect? Internal energy. State function, internal energy are 3 types: translational, rotational, vibrational. Yeah, you know this. And from this I told you this one in it's gaseous state chapter. Okay, and it is state function, so it will follow Euler's condition of exactness. Cyclic integral will be 0. Extensive property, it has a thermodynamic equation of state, and this is this. Please remember this equation of state. Please do rectification. I don't know what you are doing, but please remember this expression. This is very, very important. Please remember this first thermodynamic equation of state. This is called thermodynamic equation of state 1 with internal energy del E del Vt. That is called internal pressure of the gas. It is weird, but yeah, you have to remember this. You have to remember this. Okay. Yes, Rashmi, I will be doing that as well. Sometimes on the system plus ही रहेगा. Okay, definitely. Prakash, yes, every time work done on the system will be positive, work done by the system will be negative. Negative means work done on the system means you have to calculate plus W value. Work done by the system means you have to calculate minus value. That means whatever value you are putting, you have to put a negative sign, and that negative sign will come automatically. Don't worry, that negative sign will come automatically. Okay, automatically. Do you know why? Suppose expansion is happening. Expansion means what? V2 greater than V1, right? Yeah, V2 greater than V1. final is greater than initial, so you will be getting automatically negative value. Why negative value? Because this is your system. If expansion is happening, that means system is doing work to expand its volume. Automatically you will be getting a negative sign. Okay. And if compression is happening, compression means what? Your formula is same. You are not changing your formula. But what will happen? V1 will be more than V2. Okay. V1 will be more than V2. So if V1 is more than V2, that means your value will be opposite, because ln or like that kind of thing will be there. Automatically you will be getting positive or negative things. Got that? So you don't need to change your formula. Please tell me, got that? Yes or no? You don't need to change your formula. You just put your value, what is given. You will be getting automatically positive or negative value before the values, like before 20 joule work or 30 joule work, like that. Got this? Oh, okay, nothing to worry. We will be solving numericals on that topic too in this video. Okay. Yes, कब करवाओगे? After 20th January. In this month, after 20th January, I will be solving previous year question papers. Till then, we will be finishing all this chapter in this way. Then enthalpy. Heat enthalpy means, you know this, all these features, same kinds of feature. Okay. Heat at constant pressure is called enthalpy. Okay. Perfect. And in case of enthalpy, you have this another thermodynamic equation of state. Thermodynamic equation of state. Okay, remember, maybe you have written this thermodynamic equation of state in a different way, maybe, because whenever I was teaching you initially I wrote another form of thermodynamic equation of state. I mean, that and those are same, but I wrote another form. Okay, by mistake I wrote another form of thermodynamic equation of state, but yeah, this form is more accurate. Please, if you have the previous thermodynamic equation of state for enthalpy, for I am talking about enthalpy only. Okay, so but please change it to this. This is correct one. This is correct one. Please change it to this. Please change it to this. This is more correct one. Whenever I was teaching you, I wrote another form of this. Here I just did some changes, like another form I wrote, but this is more accurate form. Please change it to this. Okay, then finally you need to remember this expression, like H equals to E plus PV. How enthalpy and energy is important. This is very important relation. You will be understanding this in second law of thermodynamics, and as well as whenever we are solving numericals. Great. Perfect. Now, first law of thermodynamics. First law says about conservation of energy. That's all. Conservation of energy. That's all. Now, what about mathematical expression? Suppose you have system A, it has internal energy EA, and you are adding Q amount of heat, and because of that system is doing work. As system is doing work, that means minus W, because system is doing work. And finally EB, the system is going to make another state, and that state has like EB internal energy. So whenever, like in the left hand side I am having this, and in the right hand side I am having this equals to this. Yes, initial equals to final, because first law says about conservation of energy. So this energy will be equals to this energy that I have done. So from this I am getting Q equals to this and Q equals to this, and I am like writing the differential form, dQ equals to this. And finally, if we consider PV work, dW becomes minus PdV. So I have put the PdV, so it is becoming plus PdV because of this negative sign. Okay, got it? Perfect. Then for isolated system, what is what? So for isolated system, you know, that means adiabatic boundary is present. That means dq equals to 0. So if you put the value in this equation, dq equals to 0, so dE and dW becomes equal. dE and dW becomes equal means what? You know, dE equals to state function, dW is path function, state function, path function. That means dW is becoming a state function and dE is becoming a path function. That means if I ask you that under which condition your work becomes state function, because work is path function, but under which condition work is becoming state function? Simple. For isolated system, or dq equals to 0. Simple. Got this? Maybe this kind of question you face in your MCQ questions, MCQ level questions. Then what about this isochoric process? Now if I come to the isochoric process, that means dV equals to 0. So if you consider this expression, this one, and you put dV equals to 0, that means this term will vanish, dq becomes dE. That means if your condition is isochoric process, then your dq becomes dE. That means path function becomes state function, or opposite one, vice versa. Okay, great. Now coming back, Joule's experiment. So why we are doing Joule's experiment? Why we do Joule's experiment? I'm sorry, my nose is why we do Joule's experiment? Very simple thing. You know, E equals to function, E is a function of T and V. Okay, E is a function of T and V. It is very important. Remember this one. Remember this one. E is a function of T and V. Okay. Then if you do like this kind of differentiation, you will be getting this, and D will be this, and this term represents CV and this. Perfect. And CV is actually, you can measure through calorimetric principle, you can measure CV, and this term you cannot measure. So to measure this term, you do Joule's experiment. To measure this term, and after you do the Joule's experiment, I have shown you a lot of things. So what you do generally, you observe a lot of things after doing this Joule's experiment. Okay, let me drop this thing. It is not required over here. Okay. Yeah. So if you look at this Joule's experiment, after doing this experiment, you get a lot of observation. Like temperature is not changing, heat is not changing, and if these are not happening, so definitely dW P external is 0 because free expansion is happening. So P external is 0, so dW becomes 0. Okay, dW becomes 0. Yes, Shibras. Yes, perfect. Perfect. Yes, Shibras. Good. Okay. Yes. Okay, perfect. This one. Okay, great. Then how we can do this? So if I do this experiment, finally we get that D, like this result. Daily del Vt for ideal gas, I get 0. For ideal gas, daily del Vt is 0 experimentally. Okay. So from here we can say for ideal gas this becomes 0, and from thermodynamic equation of state 1 I get this expression. So if you put it, you will be getting this value, and finally this value becomes 0. I have proved it. I have shown you that why for ideal gas it is becoming 0 from thermodynamic equation of state. And I have also shown you this one like from Joule's experiment. Okay, perfect, great. For real gas, what will be the value of this? So for real gas, first of all I have calculated this value. Okay, and then finally I have put this value, and this value is becoming positive. So I am getting this value for real gas, and this term represents the internal pressure of the gas. That means as internal pressure is there, that means two molecules are giving pressure to each other, that means they are attracting each other. That's why you can liquefy like real gas. You cannot liquefy ideal gas. So why you can liquefy real gas, that you can show from thermodynamics as well, theoretically as well. Okay, perfect. Joule's coefficient, I am not showing you the complete method. Joule's coefficient has this expression. Eta is represented as del T del VE, change of temperature with the change of volume at constant internal energy, that is this, minus 1 by CV, that's the dot. This is your Joule's coefficient formula. And what about significance of Joule coefficient? For ideal gas, your Joule coefficient becomes 0. I have shown you because this term becomes 0. For real gas, like it can be positive, it can be negative. Yes. Then it's fine, it's done. Then coming to heat capacity. What is heat capacity? So in the heat capacity, I am telling you only basic things because all others are fully calculation. Okay, so I am getting one interesting questions. The value for real gas n square by v2 बोल सकता हूँ. Okay, got it. I get one interesting question. Good observation. So daily, okay, the value for real gas. You want to talk about this. nr by, okay, n square by v2, okay, let me check. nrt v minus nb minus p, nrt v minus nb, okay, minus p. Yes, definitely you can say that. A is positive, v is positive, n is positive, all these are positive. That's what I told you. Overall this term is positive. Yes, so this value means what? Actually this one, nrt by v minus nb, and this minus p. Yeah, simply that is, yeah, okay, positive. The thing that is taking care of, the thing that is important is this value should be positive. Got it? Next, Joule's coefficient is done. Now finally coming to this heat capacity. Cv means dq del q del tv equals to del E del tv, and Cp means del q del Tp del H del Tp. Remember, at constant volume very important line I am telling you. E generally present, E is present. At constant pressure, generally H present. So remember, when enthalpy is present and when enthalpy is present and when internal energy is present. So whenever you are dealing with pressure, constant pressure, enthalpy will present. Whenever you are dealing with constant volume, energy will present. These two are important. Pressure belongs to enthalpy, volume belongs to internal energy. Please do remember this. And this equation is too much important equation. Okay, great. Then I have shown you different like relations between Cp, Cv. I have shown you why Cv equals to this or Cp equals to this. I have proved it like this. I have proved it like this. I have proved it. But this proof is not important. Just remember this. Then volume dependency of Cv. So these things are like fully calculational. That for ideal gas it doesn't depend upon volume. For any other gas, yes, it depends upon volume. How that follows this expression. Okay. Then pressure dependency like yes, like for ideal gas it doesn't it is pressure independent. For any other gas it is like dependent. Okay, like that. Then relation between Cp, Cv. So I cannot like explain you in this video. So guys, can you tell me how many of you did developed the complete relations between Cp and Cv? Like I have told you different expression, different kinds of expression. Because from some expressions, question generally comes directly. How many of you did complete derivation of Cp and Cv by understanding the mathematical tools? Because I told you everything through mathematics and I taught you from the beginning to the like advanced level. What is the relation between Cp and Cv? Okay, Shumit, you did it. Anybody else? Anybody else? How many of you did it? Anybody else? Anybody else? No one. Seriously. What happened, guys? If you okay, Prakash, Patatri, only 3 students. Guys. I think you are not loving thermodynamics because a lot of mathematics are there, that's why. Okay, Arnav. For real gas, Cv is independent on volume calculation. Okay, that I have to check. Okay, because I told you to check one. I told you this one to check. Okay, that I told you show dependency because I have to check it. Okay, Kanchan, you did it. I mean. Okay. Yes, I did that. But I am telling you how many of you practiced these relations. Because look at this. How many relations? This calculation, this first relation. Then calculation is going on second relation, third relation, fourth relation, fifth relation. Like where is it? Fifth relation. E prime. This is the equation that you know. This is the equation that you know, that I have proved it. Why Cp minus Cv equals to Nr? I have proved it from thermodynamics and I have used it in gaseous chapter. So I have proved it how it is this for ideal gas. Then 6th one, 7th one, and that's all. So can you prove it? Cp is greater than Cv. I have also proved this. Don't worry, you don't need to prove it. Okay, just remember Cp is greater than Cv. Then in under which condition Cp and Cv becomes equal? First of all, water at 4 degrees Celsius, at this temperature, Cp and Cv becomes equal. Second of all, like at T equals to 0K, that is impossible like experimentally till now. So at T equals to 0K, that means at like absolute zero temperature, Cp equals to Cv. And another thing is, if temperature of a gas increases at constant pressure and volume, then there is no work done, that means Cp is Cv. But it is not possible in reality. You cannot make a like situation like that you are changing temperature and you are keeping pressure and volume both of them equal. You cannot do this. Okay, so yeah, good, perfect, Fulwani, yes, Kanchan, good. You have to do it. Okay, because if you do it, you would love it, thermodynamics. If you don't write anything, you don't love thermodynamics. Everything is about mathematics, right? If you love mathematics, if you want to love thermodynamics, you have to do derivation. And whenever you will be doing derivation, you would love this. Because there is nothing that you cannot understand like things. I told you each and every point. Yeah, let's move forward. Under which condition Cp is greater than Cp? Yes, it is also possible. Yes, it is for metastable state. Metastable state means the state that is not stable. the state that is not stable. In that state, Cv is greater than Cp. Okay. Next, calculation of Q, W, delta E, delta H. So guys, remember, a lot of 48 expressions are there. 48 expressions. So my recommendation will be, whenever you are revising, revise all of them. Revise all of them. Write all of them. Practice all of them. But before you are going for the examination, revise only ideal one. Forget about before, whenever you are revising before the examination, revise only ideal one, not the real one. Okay. So I am getting questions में confuse हो जाता है. Okay. Yes. I got it. So forget about real gas, because question I have never seen questions from real gas, and this is like very complicated expressions. So you will forget this. So whenever you are practicing, revising, understand this. Practice all these things. But whenever you are like before the examination, only revise this ideal gas. Okay. So here also I will be talking about ideal only, not real. So now let's move forward. Isothermal expansion for ideal gas. Two expressions you need to remember, other two are 0. Okay, remember, for ideal gas, all free expansion will give you 0 value. For ideal gas, all free expansion will give you 0 value. Yes, Prakash, for stable system, Cp is greater than Cv. For metastable system, Cv is greater than Cp. Okay, perfect. Then, irreversible process. Isothermal, irreversible for ideal gas. Only two, these two will be 0. I hope you can correlate this one. Coming to adiabatic expansion for ideal gas. Adiabatic means dq will be 0 every time. So first of all, dq is 0. So if you do integration, as it is path function, it will become 0. Yeah, dq equals to 0. If you integration dq, whatever limit you are putting, that doesn't matter, because it is a path function. You cannot do integration. It will become q. So for adiabatic expansion, q becomes 0. W, two things. Cv is independent upon temperature. Cv is dependent upon temperature. Nothing to worry. Today I will be giving you this kind of example in the numerical section. Perfect. Then coming to this one, delta E equals to same. You need to remember this. Cv, this same thing. Okay, one more thing that I want to tell you. Okay, so you know that for adiabatic process, dq equals to 0. So if you are putting 0 this one, that means your delta E and dE and W, these two becomes equal. So W and delta E, look at this, same to same, 100% copied, because it becomes 0, so this two becomes equal. So apply this concept to remember. Similarly, delta H will be what? Instead of CV, delta E, I told you, E belongs to V, H belongs to P. So instead of V, just put P. Here it was CV, you just need to put Cp. That's all. Got it? Next one. Adiabatic free adiabatic free, I am not talking about. Okay, sorry, it is ideal gas. Okay, so as I told you already, for ideal gas, free expansion makes all these things 0. For ideal gas, whatever process, it doesn't matter, free expansion means 0. Adiabatic irreversible ideal. So irreversible ideal means this formula. So adiabatic means q will be 0, and all other expressions that you know already. These two are common, work done will be different, minus P external, V2 minus V1, this one. So only remember this one. So whenever you are facing questions, remember guys, whenever you are facing questions, please do read the question and understand which process we are talking about. Which process we are talking about. In 99% cases, you will be having ideal gas. Okay. So please check whether it is ideal, adiabatic, irreversible, or ideal, reversible iso, or ideal, reversible adia. Please check that one first from the question. Okay. okay, Shubhi. Okay. Fine. And forget about real gas. I am ignoring this for the time being. Whenever you are practicing, practice. But before the examination, do not practice this. Okay, forget, because nobody can remember these things. Forget about real gas. Coming back, okay, there are some important relations. Yeah, these important relations are really important. That's why I have written important relations. Okay, these are really important, guys. These are really important. Okay, first of all, relation between pressure and volume for adiabatic reversible ideal. Do also remember this process as well. Okay. And before I go to that, I am getting one comment that is सर इस कंडीशन का एग्जाम में कैसे पता लगेगा कि ये जीरो ही होगा? कंडीशन कैसे पता लगेगा? आपको याद रखना, you have to remember that whether it will be zero or not. You have to remember that. You have to remember the value. For free expansion, you have to remember the value. And how would you understand that which process we are talking about in the question? So in the question, if you read the question properly, in the question they will be giving you the process, whether it is whether it is adiabatic or isothermal, whether it is reversible, irreversible or free, or whether it is ideal or real gas. They will be mentioning in the question. Maybe they are not talking about adiabatic. They say heat is not changing. That means dq equals to 0. So dq0 means what? Adiabatic. So directly they may not talk about, but indirectly they can talk about. Suppose isothermal. They are not saying it is isothermal. They are saying temperature is not changing. Temperature is not changing means what? Definitely isothermal. Clear or not? Please tell me. Did you understand this point? That whether they are giving directly or they are giving indirectly, you have to understand that. Clear or not? Please write down in the comment box. Clear or not? Please write down in the comment box. Perfect. And that you have to understand from there. Even sometimes what happens, they give no gases, like whether it is ideal gas or real gas, they don't mention. They only say gases. And whenever they are saying gases, that means they are making your job easy. They are talking about only ideal gas. They are not talking about real gas. So these kinds of things that you can understand from practice. Okay. But I am telling you because of my experience that sometimes they say only gas. That means they are talking about ideal gas, not real gas. And sometimes what happens, they are not talking about real gas. They are talking about gas, but they have given you A value, B value. A and B value is what? Van der Waals constant. A and B, these are Van der Waals constant. That means they are talking about real gas. But whenever they are talking about only gas and no A value or B value is given, that means they are talking about ideal gas. Clear? Right? See if it is clear. Okay. So first of all, adiabatic, reversible, ideal. In case of this process, PV to the power gamma equals to constant. That means this. For like T and V, relation between TV for adiabatic, reversible, ideal, TV gamma minus 1 equals to constant. Okay. Similarly, relation between T and V for adiabatic, reversible, real. So don't remember. Do not remember this one. For real, do not remember. I told you. Because you can't remember. Now you practice. Now you can practice. But before the examination, like 10 days or 5 days left, do not remember this one. Or 2 days left, do not remember this one. Okay. Perfect. Now, relation between, look at this guys. Whenever I was like talking about, whenever I was teaching you, please listen carefully. Whenever I was teaching you, I talked about only adiabatic, ideal. Okay. I didn't talk about this expression. I added this expression later on. But this expression is very important expression. Okay, very important expression. Please. So it is, this expression is true adiabatic, ideal for reversible process, and this expression is true adiabatic, ideal for irreversible process. So focus on this term, reversible and irreversible. Okay, reversible and irreversible. So from the irreversible process, in 99.99% cases, they will ask about final temperature T2. They will ask you to calculate final temperature T2. So I will be editing my video and upload it over there. But for the timing, please note down this expression as well. This one is for reversible process, T gamma P to the power 1 minus gamma constant, and this one is for irreversible process. And this equation you have to remember. This is very important equation. Please. From here, what kind of question you will be facing from this formula? Calculate final temperature for adiabatic, irreversible process. Okay, please do it. Okay, please note down it. I am holding here. Open your copy. Wherever you are like making note, like you are making notes, please add this expression. One question I am getting, reversible and irreversible अगर नहीं बोला directly, then कैसे बोलेगा? Okay. Sometimes what happens, they will not say like it is reversible, it is irreversible process. Sometimes they will not say reversible odd or irreversible odd. Sometimes they suppose they are talking about some like P external. Sometimes they are talking about suppose P external. So P external means that will be the irreversible process, because in reversible process P external, P internal, all pressure are becomes equal, because those are in equilibrium. So now I didn't tell you, because I will be talking about that whenever I will be solving numericals. Okay, whenever I will be solving numericals. So have you noted down this expression? Have you noted down this expression? And this expression is for 1 mole. That's why I have written CVM for 1 mole system. And here instead of NR I have put just NR, only R, because number of mole is 1. Have you written this? Have you noted down this? Good. Next, move forward. This expression. So comparison between adiabatic and isothermal process of ideal gas. First of all, adiabatic means PV to the gamma, isothermal means PP gamma. For this process, okay, final volume in case of isothermal process is more, final volume in case of adiabatic process is less. So guys, I know that you cannot remember a lot of things from this kind of thing are very tough to remember. So I am telling you a shortcut method. Shortcut method is this. Shortcut method is this. Okay, how? Just look at this plot. Just look at this plot simply. This plot belongs to isothermal process. This plot belongs to adiabatic process. Okay. This plot belongs to isothermal. This plot belongs to adiabatic process. Okay. So pressure in isothermal is more. Pressure in adiabatic is less. Now volume. Fine. If I talk about final volume. Okay. Final volume. So now look at this. At any pressure. Suppose I am considering at any pressure. This pressure or this pressure. Suppose I am considering this pressure. So if you consider this pressure, look at this. This is your volume for adiabatic. This is your volume for iso. So volume is also more. So for isothermal, volume is more, pressure is more. Adiabatic, final volume is more, final pressure is more. Final volume is less, final pressure is less. Okay. And if I talk about the slope, okay, the slope. What about slope? So you can understand this is like this kind of thing. This is like this kind of thing. So I can say this adiabatic curve is more steeper than isothermal curve. So this will have adiabatic curve will have more slope. It will have less slope. Okay. So these are the things that I have already told you. Perfect. Remember, P2 iso more, adia less. P2 iso more, adia less. Slope adia more, iso less. Just remember this plot. Above one is iso, below one is adia. Perfect. Then work done. Work done in isothermal reversible process is total work done is this, like total area under the curve, this area, all this area. Okay. And if I talk about this area, this belongs to adia. So definitely more area means more area belongs to isothermal process. That means isothermal has more work than adia. Similarly for irreversible work, same is true. Next, another experiment you are talking about, that is before thermochemistry we are talking about another experiment that is called Joule-Thomson experiment. Joule-Thomson experiment means, so we know this one and finally we get this one. So we can calculate Cp, but we cannot calculate this term. Okay. So to calculate this term for real gas generally, or to calculate this term, we generally set up Joule-Thomson experiment. So for Joule experiment, we know E is a function of T, V. And from this we are doing, we don't know this kind of term and we do Joule experiment. And for Joule-Thomson experiment, H is the function of this and we don't know this term, and to understand this term, to know this term, we are doing Joule-Thomson experiment. Simple. Now more specifically what happens, if I talk about Joule-Thomson experiment, generally we get this value equals to 0, like the Joule experiment. Del E, del Vt equals to 0, and that means, like, let me show you, del A is del Pt will be also be 0 for ideal gas. For solid and liquid we get this kind of value, but for real gas this value is not 0. So to calculate this value for real gas, generally Joule-Thomson experiment is set up. So this value we need to calculate, that's why we are setting up Joule-Thomson experiment. But we can easily calculate that for ideal gas this value becomes 0, for solid liquid we generally get this kind of thing, but for real gas we cannot calculate this value. So to calculate this value we generally set up this Joule-Thomson experiment. Okay. Perfect. Setup is like this. I am not going to show you what are the like different kinds of thing. What we are considering, that is irreversible change is happening. Why irreversible change? Because porous plug is there, so more pressure to less pressure. Like here less pressure, so external pressure is less, so that will like from here, from this chamber, your gas will be transferred to this chamber through porous plug, right? Through porous plug. Perfect. And remember, so observation is what? Temperature decreases, and as in this process, whenever gas will go from this chamber to this chamber, temperature will decrease, and whenever temperature is decreasing, so this decrease of temperature will be called Joule-Thomson cooling. Joule-Thomson cooling. Okay, simple. And what is the conclusion that you are getting? That except hydrogen and helium gas, hydrogen and helium, it will be helium. Okay, helium. Except hydrogen and helium gas, all gases will show adiabatic cooling. Okay, perfect. Then I have shown you that this this experiment is isoenthalpy experiment. Then I talked about Joule-Thomson coefficient. Okay, this is the expression that at constant enthalpy, change of temperature with the change of pressure, that is called Joule-Thomson coefficient. Then I told you like that in this process, in this expression process, this Joule-Thomson experiment is isoenthalpy experiment. So guys, can you tell me which process is called isoenergetic process? Which experiment is called isoenergetic experiment? Can you tell me? Can you tell me which process or which experiment is called isoenergetic experiment? Isoenergetic means delta E will be 0. Here it is Joule-Thomson experiment is isoenthalpy. That means delta H equals to 0. That means delta H equals to 0. Okay. That means, okay Akash, very good. Joule's experiment is called isoenergetic process. Prakash, what about adiabatic cooling? I am not talking about adiabatic cooling. I am talking about Joule-Thomson cooling. Okay, Joule-Thomson cooling. Please look at the video. I talked about this cooling is called Joule-Thomson cooling. Adiabatic cooling is a different kind of cooling. Okay, maybe in that video I talked about, by mistake I talked about adiabatic cooling in place of Joule-Thomson cooling. But yeah, you have to understand that this is about Joule-Thomson cooling. Okay, adiabatic cooling is different cooling that we don't need for this time being. Okay. Yes, Joule experiment. Perfect. Good job. Now we don't need to prove it because it was a part of this process. Now, inversion temperature. Inversion temperature means at inversion temperature neither cooling nor heating will be observed. Yeah, perfect. Or at inversion temperature neither cooling nor heating will be observed. But if you go above inversion temperature, heating will be observed. Below inversion temperature, cooling will be observed. Then different kinds of value of mu J and different kinds of systems. So like we talked about different kinds of thing. Okay, so these cooling methods are likely to be like Joule-Thomson cooling. These are likely to be Joule-Thomson cooling. Change it. Okay, change it to Joule-Thomson cooling. So if you have watched my video recently, I have edited those parts. By mistake I talked about adiabatic cooling. This is called JT cooling, Joule-Thomson cooling. Okay, so if you had seen my video recently, I changed that, but if you had seen my video previous, so in that case I didn't change it. Okay, so it is Joule-Thomson cooling, not adiabatic cooling. Adiabatic cooling is a different kind of cooling that we don't need to understand right now. Then expression for JT experiment, right? This JT, mu JT, that means Joule-Thomson coefficient has value this. Okay, this is this. Okay, perfect. Joule-Thomson, this expression you need to remember. This expression you need to remember. Either you remember or you remember how you can get this expression. You can get this expression starting from this, because you know this already. And check how you can do this. Just make your enthalpy equals to 0. Just practice twice, you will be getting it. Just practice twice, you will be getting it. Yeah, good Prakash. Next, finally, at inversion temperature, like Ti equals to 1 by alpha. Okay, so suppose alpha means what? Remember like coefficient of thermal expansion, alpha equals to 1 by phi. Remember del V del T P, like that. So coefficient of thermal expansion. So how inversion temperature and coefficient of thermal expansion, these are related. Only remember these expression. Don't need to like derive. Only remember this expression. Okay. Okay. So Arnab is asking for real gas, explain the Joule-Thomson value. There is no Joule-Thomson value. Joule-Thomson coefficient is there. Okay. Perfect. So I told about like how you can calculate JT value for ideal gas. So I got value what? If I put this value over here, I got value 0. Mu JT is 0 for ideal gas. Okay. And I told you calculate the mu JT for real gas. So for real gas, this value will not be 0. You will be getting a positive value. But nothing to worry, you don't need to calculate that. But if you want to calculate that, you can do this. So I am not doing this. Please don't like tell me to do like a big derivation and that will take like 30 minutes. Please don't do it. Don't tell me. If you, I told you how you can do this, how I have done this. Please do the same thing in this way. Please, if you are stucking, then ask me in the WhatsApp group. I will be helping you. But don't tell me right now to do this. Please, it is just wastage of time because never they will ask you to calculate this value. That's why I have given you as your homework. This may be important. This is easy. So they will ask you this one. Okay. Never they will ask you to tell the value for this one. But try it at your home. Done. First law of thermodynamics is done. Thermochemistry. So we will be understanding thermochemistry in a different manner. It will take only 5 to 10 minutes. Then we will be moving forward to numericals. Okay. Thermochemical reaction. You know this. In case of thermochemical reaction, you have to mention the stoichiometry. You have to mention the represent the physical state like liquid, solid. Stoichiometry, that means balanced equation. There should be mentioned temperature, pressure, and enthalpy. Temperature, pressure, and enthalpy change. Enthalpy change means positive or negative value. So whenever you are getting this product from the reactant, how much enthalpy you are like, what is the enthalpy change? It has some enthalpy, it has some enthalpy. What is the change whenever you are getting product? That is called delta H. Delta H means enthalpy for product minus enthalpy for reactant. Okay. And if it is positive, the delta H value is positive, that is your endothermic reaction. That means you are adding heat from the outside. That means you are doing work on the system. That means positive. And whenever exothermic means system is releasing temperature. That means after the reaction will be responsible to release the temperature, to release the heat. That means system is doing work. That's why it is negative according to IUPAC rule. Simple. Yes sir. Now इसलिए मैंने homework दिया था उसको. Perfect. Now temperature dependency for thermochemical reaction. I am not going through this. Because you know this already. Here remember Cp is dependent on T, Cp is independent on T. This factor I will be using sometimes up later. Okay. Then yeah, I am not showing you the derivation once again. It is easy. Pressure dependency. We got what? We got that it is not pressure dependent. Okay. Yes. Is pressure independent? I told you is pressure independent. I proved it. Okay. Then standard state, I told you standard state means pressure should be 1 atm. Sometimes you can consider 1 bar as well. Okay, in some books we consider 1 bar, in some book 1 atm. So in maximum cases standard state means 1 atm pressure. Temperature should be a particular temperature there should be. Okay, and yes, it's fine. Okay, now you have these two reactants and you are getting this product. Okay, and enthalpy change is happening because whenever this reaction is happening. So these enthalpy change, whenever this reaction is happening, that is called enthalpy change of reaction or enthalpy change for this reaction. Okay, or enthalpy of reaction. Simply enthalpy of reaction. This delta HR is called enthalpy of reaction. Enthalpy of reaction. Perfect. And how would you tell you about this standard state? You have to put a 0. Standard state means these conditions you have to fulfill. You have to put a 0. 0 means standard state means 1 atm pressure at particular temperature and like a particular stable state the system should be in. Okay. Different kinds of heat of reactions there, formation, combustion, and a lot of things. I am not discussing this because this will be easy whenever we will be solving numericals. Hess's law you know already. Hess's law means likely to be yes, A plus B to this C, and like in one step if you do any reaction the enthalpy change delta H1, and if you are doing the same thing and you are going to the same product through multiple steps, so these enthalpy change will be equals to summation of all other enthalpy change. That is Hess's law. Know this, you know this already. Then I have given you different kinds of application of Hess's law, so I am not telling you about this application for the time being. Why do you know? Because we will be calculating a lot, we will be solving a lot of problems regarding that. Yeah, that's why I am not telling you about this heat of, what is heat of formation, heat of dissociation, heat of bond breaking, like that. Two important formula you need to remember. One is delta H equals to delta E plus delta nRT. This formula, delta N means what? Number of moles of product minus number of moles of reactant. And another thing is this one, you know this already. Forget about that. Okay, not forget. Suppose A is one element, B is another element. Suppose A and B, these are two different elements, right? A and B, these are two different elements. And finally, I am getting AB. It's a product, it's a compound molecule. But these are elements. Like suppose it is carbon, it is suppose another element. So now guys, if these two element means what? Only one atom is there. Okay. So for this reaction, because one mole of product is forming, that's why I am telling you it is delta HF of AB. Yeah. Enthalpy change is this. Now tell me, this enthalpy change will be how equals to only, I am ignoring this delta value like H0AB. How I am ignoring this? It is very simple method. Do you know what? So enthalpy of product, enthalpy change of product during this delta HF. And if you talk about enthalpy change of this and enthalpy change of this. So now tell me, can you form this element through chemical reaction? Suppose it is a carbon. Can you form carbon through chemical reaction? You will be saying, okay, I can derive carbon. No, I am not talking about any reaction product. I am talking about form. Can you form carbon? So carbon can be formed through nuclear reaction, not chemical reaction. So if this is because this is one element, and you cannot form this element. So what happens for these kind of elements? We consider that its enthalpy change is actually 0, because you cannot form this. You cannot form this, but you can form this AB. So it has enthalpy, that is delta HF, enthalpy change. So overall reactions enthalpy will be what? Enthalpy of this minus enthalpy change of this. So its enthalpy is actually 0, but its enthalpy has a particular value, suppose X value. So delta H means what? Product minus X minus 0, product minus reactant. Yes. So this two is 0. That means this X is actually nothing but this. Its enthalpy is enthalpy of X means its enthalpy. So its enthalpy is equals to overall enthalpy change, because enthalpy change means what? Product enthalpy minus 0, because these are elements. So X means what? Delta H. That's why delta H equals to H only, because other will be minus 0. This will be 0, nothing is there. That's why if I consider element, because you cannot form element through chemical reaction, you can form through nuclear reaction, but in chemistry we will be dealing with chemical reaction only. That is why delta HF becomes HF. Simple. You have read this thing in your 10+2 although as well. If you can remember, if you can open your 10+2 thermodynamics books, this thing is written already. Please do open once. Okay. Finally, okay, that's I have told you. Conventionally, it is taking 0. Okay. Finally, QP equals to delta H and QV equals to delta E. This you just remember for your simplicity. Yes. Now finally, proton affinity, you know this, Born-Haber cycle. What is proton affinity? Born-Haber cycle I talked about. Yes. In Born-Haber cycle I talked about in solid state. Okay, perfect. Second law. So first law of thermodynamics and thermochemistry is done. So now let's move forward to the numericals. So guys, I am taking 5 minutes break, okay, because I can't talk too much, because I am giving you questions, you solve it, nothing to worry. I am giving you question, but I am taking 5 minutes break. Okay, 5 minutes break I am taking, just solve it. Okay, I just don't want to talk for 5 minutes. You have to solve this question. Solve it. First of all, please do listen. During solving numericals, please, I am requesting you, please write that whatever informations are given in the question, please write those. Then try to solve numericals. Without writing that whatever informations are given, you cannot solve your numericals, or you will be doing mistakes. Write whatever informations are given and write the corresponding units as well. Please. I am coming back within 30 seconds or within 1-2 minutes. Okay, just solve it. I need answer. I have already solutions, so I will be showing you solution and explaining you, but I need solution. Okay, whenever I am telling you to solve numericals, students are starting leaving. Okay, they are not comfortable with this. You are thinking I will be solving numericals. Yeah, definitely I will be solving those. But you are here to try. If you don't want to try, then what will happen? Whenever I am telling you to solve numericals, you start leaving. Don't be lazy. Okay, if you are becoming lazy, you will be having. I am talking from the last 1.5 hour. I am continuously talking. So if I can, you can also do some like hard work, right? Okay. One answer I am getting -2740 joule. Okay, good. Okay, I am waiting for another answer. So there are two questions, two things. Like they are asking like 1 mole. Okay, let me give you the information. N equals to 1 mole. Okay, perfect. Oxygen gas, right? Temperature equals to 300 Kelvin. Expansion is happening, right? Expansion is happening. That means like V2 minus V2 is greater than V1, like the isothermal. dt equals to 0. Isothermal, okay, it is given. From 3 atmosphere to 1 atmosphere. That means P1 is 3 atm. P2 is 1 atm. Anything else given? Okay, assume that oxygen behaves ideally, calculate W. We have to calculate work done, W. So work done in which process? First of all, look at this. It is an isothermal process. You got isothermal, okay? Isothermal process, okay? Isothermal process. And now you have to consider isothermal, reversible, and oxygen is behaving ideally. That means ideal. This is question number 1. Question number 2, what? Isothermal, irreversible, ideal. Single step against constant pressure of 1 atmosphere. So P external is also given for this. P external is given 1 atm. So look at this. Every informations are given. You just need to apply the formula. Okay. Arnav, you are getting -2740. Okay. Shift rise is you are getting minus 2470. Okay. 0.12 joule per mole. Okay. Nearly 2600 Prakash. Let's see what happens. Your answer is here. 2740. Arnav, you are absolutely right. Shibras, you are absolutely right. Arnav and Shibras, you are both of you are absolutely right. But remember, I told you guys, there should be negative value. Shibras, negative value there should be. Arnav, you are absolutely right. 2740. So it is in kilojoule. So it will become what? Here the negative sign. Look at this negative sign. Please look at this negative sign. So you should transfer this negative sign from here to there. Yes. So yes, that the value will be minus 2740 joule, or in kilojoule this will be your value minus. Okay. In examination you have to put negative sign. Perfect. So look at this. You just have to do normal mathematics. This formula. W reversible equals to minus nRT ln V2 by V1 or P1 by P2. So this expression I am using because P1, P2 these are given. P1, P2 are given. Look at this. P1, P2 are given. N is given. R you know already. T is given. T is means what? Temperature 300 K. So R value will be what? Look at this guys. You may get confused about this R value. So it is what? It is your like pressure in ATM. But remember, it is ATM. ATM will get cut. So you want to get work. Work unit should be joule. So R you will be putting in joule. So ATM will not disturb you. This ATM pressure will not disturb you. So you may think that I have, as pressure ATM is there, so I have to like put liter atmosphere like 0.082. But you don't need to put it. Why? Because ATM and ATM they are getting cut. If I write P1 ATM and P2 ATM, they are getting cut. So there is no pressure unit. So you can easily put R value in joule, so that work value you can get in joule or kilojoule. So maybe in your examination, they can ask that put the value in joule or put the value in kilojoule. So you have to be very careful in that. Good. Yes, Arnab, you are absolutely right. Minus, okay, good. So minus W means minus P external V2 by minus V1. P external is there, V2, V1. So now here you will be doing, you may do your mistakes. So first of all, let me tell you, did you understand the first one? I am not talking about second one right now. Did you understand the first one? Yes or no? Did you understand the first one? Did you understand the first one? Forget about this part. Only look at this part. This is the first one only. Did you understand? Only look at this part. Then I am explaining the second one. Nothing to worry. Okay. Perfect. Now coming to second one. So in case of, okay, so for reversible process, what is your formula? You know the formula. Let me remind you once again. W reversible equals to what? Minus nRT ln V2 by V1 or minus nRT ln P1 by P2. For irreversible process, minus P external V2 minus V1. Okay. Now you need to know this V2 minus V1 term. How can you get that? Simple. It is your ideal gas. Look at this ideal gas. So you know ideal gas expression? What? PV equals to nRT. So P1 V1 equals to nRT. Isothermal process, that means temperature is constant. So you don't need to put T1 T2. Temperature is constant. Yeah. So from here, you know P1, you know N, you know R, you know T, so you can easily calculate V1. Similarly, you can easily calculate V2. V2 equals to nRT. Perfect. Yeah. So that's what I have done first. V1 will be equals to RT by P. I mean RT by P1. Why? Because forget about this. V1 will be equals to what? V1 will be equals to nRT by P1. N means 1 mole. It is given. R means, look at this. Here I am putting value in 0.0821. Yes. And DMQ means liter. Okay. Liter, atmosphere, mole inverse, Kelvin inverse. Why I am putting it this value? Because here it is a pressure term. Look at this. V1 will be nRT by P1. Okay. Pressure term. So pressure is in atm. So you have to cut this 2. And then 300K. So finally you will be getting this Kelvin and Kelvin inverse will get cut, mole inverse, mole will get cut. So only you will be having DMQ or liter. DMQ means liter. Remember, 1 DMQ equals to 1 liter. Okay, perfect. So just put it in DMQ liter. So if you put it in liter or DMQ liter, volume is in liter. Okay, or DMQ, simply put it, keep this value, nothing to worry. Okay, nothing to worry. So it is your DMQ. Okay. Now similarly you can calculate V1. I mean V1 means for this P1 pressure. For P1 you can calculate V1. Similarly for P2 you can calculate V2. And you can calculate in this way, and your value is this. So two values you are getting. One value is this, another value is this, and the unit is DMQ or generally liter. So from liter you can easily convert it into SI unit, because if you want to use this expression, W equals to minus P external V2 minus V1. Okay. Then your DMQ value, DM means decimeter, like decimeter cube. You have to convert this DMQ. Okay, forget about DMQ. It is considered as liter. Okay, let me change it. Yeah, liter value. Okay, liter. DMQ means liter simply. Liter means what? So you know relation 1 liter equals to 1000 cc, and cc means what? 1000 centimeter cube. Centimeter cube means 1 centimeter cube equals to, okay, that means 10 to the power minus 3 meter cube. From centimeter I can easily convert meter. Okay, so centimeter cube means what? 1 semi into 1 semi into 1 semi. 1 semi means 10 to the power minus 2 meter, 10 to the power minus 2 meter, 10 to the power minus 2 meter. So meter cube, and minus 2 10 to the power minus 6. So 1000 into 10 to the power minus 6, that is 10 to the power minus 3 meter cube. So 1 liter equals to this meter cube. I get it. So put it. This liter equals to multiplied by 10 to the power minus 3 meter cube. So why I am making this meter? That means I am changing it to SI unit. Simple. Changing it to SI unit. SI. I have got my value V1 SI, V2 SI. Now put pressure. Pressure is what? 1 atm. It is given. External pressure is 1 atm. It is given. 1 atm means what? You know this in SI. 1 atm means what? 1.013 into 10 to the power 5 Pascal. And Pascal means what? Pascal means, you know, 1 Pascal means Newton per meter square. Pascal means Newton per meter square. Newton per meter square is the unit in SI, or Pascal in SI. So put 1 atm in SI, this value in SI. So finally you have to take care of the unit as well. Don't like skip those unit. This one is there, do some like this kind of subtraction, do this subtraction, meter cube meter. So if you do this meter cube meter, you will be getting Newton meter, and Newton meter means what? Joule. So Joule, so from Joule you can convert it into kilojoule. Simple. Newton meter means what? Joule. Okay, so please be patient and please do solve like slowly. Once you learn these techniques, once you like, it's okay, your motto, remember, your target will be all these terms you have to cut. So you know that work has a unit joule. Yes, you know this. Work has a unit joule. Simply you know this unit. So you have to make joule. So to make joule, what I have to consider. So you have to play with unit as well. You cannot ignore your units. That's why I have written everywhere here unit is written. I have made all these SI units. So first question is very easy because ATM ratio, they will get cut. You can take any R value. As work done you want to calculate in Joule. So I put R value in Joule simply. But in the next case, volume, you have to play with volume. So volume means liter. Liter is not SI. Meter cube is SI. So liter means 1000 cc, 1000 centimeter cube, 10 to the minus t meter cube. Just put it, multiply it, it's done. Clear or not, please tell me. Clear or not, please tell me. Clear or not if you still have confusion. And that's why I tell you, after this live session, please do solve all the questions once again. After this live session, please do solve all the questions once again, so that your confusions gets like 100% clear. Clear or not, please tell me. If not, please tell me. I am explaining once again. Please, once this live session is completed, do solve all the questions. Yeah. Next one, next question. This question is done. Next question, you have 2 minutes to solve. So first of all, write down that which informations are given already. I am writing down all those things. Then your job is to your job will be to solve this question. Okay, your job will be there to solve this question. Yes, this is a very interesting question. You have to calculate work done. So work done means unit will be either joule or kilojoule. So you have to make it. That's how you have to play it. Okay. Can I use nRT into 1 minus P2 by P1? Yes. Shonu, relevant Shonu. Yes, you can use that. Yes, you can use that. So a lot of methods are there, but yes, I have also derived that expression as well. I have also derived. Okay. Like guys, one more thing. One comment I have got, actually that is very interesting thing. Okay, so P is constant. So yes, P is constant. P is constant. Listen. P is constant. P is 1 atm, right? Okay, let it go. Do it, because for other questions, otherwise you cannot solve this. If you follow this equation, whatever Shonu is telling, it is applicable only when P2 is equal to external pressure. If P2 is not equal to external pressure, then we cannot use this expression. Okay, so it is general expression. Learn from this. Yes, solve this. Solve this one. So first of all, forget about B, only solve A for ideal gas and tell me the answer. Can you tell me which R value you will be taking? Okay, just okay, solve it. Solve your problems, then just solve your problem. Yes, Ramu, hello. We are solving numericals. Okay. Isothermal, reversible, ideal. Same formula, guys. Okay, Arnab, good. What should you do? Sleep, sleep. I won't say you that whenever you are getting feeling sleepy, just read and get motivated. Just sleep, and then whenever you are waking up, start your job. Start doing your job. Suppose you are sleeping now, wake up at 4 a.m. Simple. And if you are sleeping at 2 p.m. at 2 a.m. at night, woke up at 10 a.m. Simple. 5 minus 5743. Okay. Two students are answering. So let me give you. Yes. 5743, 5744. Very good. Yes. Awesome. Good, Fulwani. 5 minus 5743 or 44. Both of them are right. Both of them you are right. Okay. If you write 5743, 5744. Yes. Perfect. Look at this. It's given. So you don't need to follow this solution method, you just need to follow this method. Next, what about real gas? What about real gas? Don't just see the answer, just calculate this for real gas. Can you do this? What about real gas? If you can't remember what about real gas, just do one thing, just go for the expression that I told you. Just go for the expression that I told you. Isothermal, reversible, real. Just go for the expression. Okay, let's see. I am giving you a little bit hint. Okay, how to choose. Okay, this video is not for this. Okay, Ramu, this video is not for this, so I won't talk about this. Okay, this video is not for this, not about this, so I won't like distract the students. Okay, so we'll be talking about this topic later on. Okay, yeah, 1 year gap is a good option. Okay, 1 year gap is a good option, but after taking 1 year gap, you should get result. If you are not getting result, then there is nothing like in your life. You will be taking gap, like 1 year can be wasted anytime. But if you are utilizing your 1 year gap, your 1 year to make your future better, it doesn't matter. It doesn't say it is not like getting wasted. Okay, so you can take this, but after 1 year you should have result. That is the thing. Parents will be okay. Parents, don't go with the parents. Whatever you are thinking, just go with them. But remember, whatever decision you are taking, that you have to make those things true. If parents find that whatever you are saying, and after 1 year you are not getting anything, no results, whatever you are expecting, you are not getting anything, then they will get tensed. Okay, so don't make them tensed. So you can ignore parents, but if you are listening to yourself, then utilize your 1 year and do one thing. Just remember one thing, that your year shouldn't get wasted. Okay, that's the thing. Parents will say anything because they love to stay in the like safe zone. They love to stay at the safe zone, so that's why they are telling something. Even my parents are telling that kind of thing also, but I am not interested in them. Okay, show the question. Okay, you just need the question. Yes. Yeah, got it. And remember, after 20th January, we'll be solving new, previous year question papers. Okay, previous year question papers. Then you will think, okay, this is too much easy. Even if you try to solve previous year question papers right now, then you will be finding all those things are like present. All those formulas, whatever are used to solve previous year question papers, I have done all those things. Okay. So you will get confident. You will be getting confident, right? This question is the same question. Okay, how much time you will take? Okay, take your time, but give me right answer. I need just right answer. Don't do calculation in mathematics. Whenever you are calculating, don't do like calculation in mathematics. And one more thing, that generally whenever you are solving numericals, use this calculator. Use this calculator. Okay, so this calculator is the same that you will be using in IIT JAM examination. Fine, same calculator. So that's why I'm telling you, do use this calculator, so that you can be familiar with this calculator. Otherwise this calculator will be used like if you are using Casio ES Plus, that is very efficient calculator. You won't get that much efficient calculator in your JAM examination. So use GET calculator to solve your numerical. Okay, to solve your numerical, use GET calculator application that you will be finding, I think, in Play Store. That you will be finding in Play Store. Yeah, I know this. You are using Casio because we are like very lazy. Casio, you can put all these values. You can put all these values at once and you will be getting your answer. But in IIT JAM examination, you won't get this calculator, that kind of calculator. Even, do you know one reality? Do you know one reality? I didn't buy a single calculator in my life till now. Okay, I never bought a calculator. I never bought any calculator. That is my, like, whatever in in important examination, I just took calculator from my second bench students. Please share your calculator, and I did this for whole of my life. Okay. So I never bought any calculator. Even I don't have any calculator. Now I use mobile application like this. If you don't have Casio calculator, I am using this calculator right now, like at this moment. Look at this. The same calculator, same Casio calculator. Okay, I use this one on my mobile. Normal calculator. Okay, use this one. This calculator is same font of like IIT JAM examination calculator. Okay. Okay, गेट कैलकुलेटर में एक बार कर ले. Okay, okay, कर लो. Do it in GET calculator. Okay, what answer you are getting? I think you are getting correct answer. Are you getting it, guys? Please tell me. Are you getting it? Please, if you done it, if you have done it, I am moving to the next question. Should I go it? Should I go for the next question? Because just you need to put your values. Or need some 2 minutes or 1 minute time. Please do mention now. Please do mention right now. Should I go for the next question? Arnab, what happened? Arnab, Shayani, what happened? Prakash, Fulwani, Kundan, Akash, what happened? Did you get this answer? By applying solve it in your way. Don't follow this one. Okay, don't follow this one. These are shortcuts. Just follow your method. Just use this expression, then do calculation. I need comment from everybody. I think I can't finish this one. Okay, I have to take another class tomorrow morning to finish this one. And yeah, tomorrow I will be starting chemical equilibrium. That will take very less amount of time. That is very easy chapter. Chemical equilibrium is very easy chapter, and ionic equilibrium we have already read in your 10+2. Okay, 5546, 5770, 5542. Okay, Arnab is very close. Shayani, please graph wale questions practice kar do. Graph. What you are talking about? Which chapter? Graph means which chapter? Okay, Joule. Yeah, Shayani, you are good. You are quite good. 5770. But here I am getting 5542. Did you do any mistake? Did you do any mistake? Did you do any mistake? Okay, thermodynamics graph from thermodynamics. Okay, like you are talking about like isothermal, reversible, those kinds of question, right? Isothermal, adiabatic carb, that kind of question, right? How the carb will look like, this kind of question, right? This kind of question you would face in IIT JEE examination. Why JAM examination? Okay, if you are asking, then I will be doing it. But this kind of question I have never seen in IIT JAM examination. Graph type questions I have never seen. That those questions generally come in IIT JEE examination, JEE main and advanced examination. So please do your calculation once again so that you get this exact value. If you are getting 5770, that means you are right. Maybe here some mistakes are there, but Arnab is getting same value like written over here, minus 5546. Please do solve it accurately. Moving to the next question, this one, solve it. This question, solve it. So first of all, write what are the informations, those are given. Write the informations, those are given. Can you calculate or should I tell you the solution? These informations are given, you have to calculate the temperature change. Whenever the system is doing work, what will be the temperature change? Can you calculate or should I try? Should I give you the solution? Can you calculate or should I give you the solution? Okay, try. Okay, take your time. But I think I can't finish all those questions today. Okay, I will be finishing only first law and thermochemistry. I will be solving tomorrow morning because it will become 12 p.m. then also 12 a.m. then also I can't finish all this because you are taking time. Because yeah, it's okay. Take your time, but don't like compromise. Take your time, but do not compromise. You have time, take, but do not compromise. And what I will be doing, I will be sending you the questions. Like I will be showing you the questions. Take the screenshots. Take the screenshot of those questions and try to solve it at your home. Okay, sorry. I will be solving the question. I will be giving you the questions. Fine. And take the screenshots. Okay, 1 more minute. If you don't answer me that should I discuss or not, I will be showing you the answer. 1 more minute. $60K. Okay, very simple thing. So from first law of thermodynamics says this thing, right? Forget about this thing, forget about this expression. I am writing delta E equals to Q minus W, or I can write Q plus minus W in this way. And here already it is written that work done is what? Negative. I have told you work done is negative. That means I am putting just normal value. 200 minus 15. That's how. That's why. Okay, done. So just delta E will be equals to just one second. Delta E, not delta E. Q equals to delta E minus W. So delta E equals to Q plus W. Now it is better. This is your first law of thermodynamics. So first of all, delta E I need to calculate. So delta E value you are calculating. Q value is given 200 joule. W is given minus 50. W is minus 50. Delta E calculated is 150 joule. Yes. Delta is 150 joule, and you know delta means what? For vibrational modes are inactive, so only rotational and rot plus trans you have to consider for diatomic molecule. So it is 3/2 R. It is R only. Perfect. 3/2 R and R. That is what total delta E. 5/2 R. Okay. So 5/2 R is total delta E. Okay. So total. Okay. Yeah. So you know this expression already. Why should I write? Yes. Delta E equals to CV delta T. Delta E equals to CV delta T. Okay, Arnab, why you are okay? It is not delta T value. Okay, it is not delta E value. It is CV value. CV. You know this expression, right? Delta E equals, remember delta E equals to CV T2 minus T1. T2 minus T1 means what? Delta T. So CV value is what? CV value is this for rotational, for translational. So total CV value means 5/2. 5/2 R. There is total CV value, CV total. So now what will happen? Delta E equals to total Cv 5 by 2 R delta T. Delta E equals to Cv delta T. Now from here you know delta E value, so delta T will be what? Delta E into 2 by 5 R, delta E divided by 2 by 5, I mean 5 by 2 R. Put the value 7.2 Kelvin. Okay Arnav, you are good. 7.2 Kelvin. Perfect Arnav. Good job. This question was interesting, right? Yes or no? Please can you tell me in the comment box whether this question was interesting or not? This question was interesting, right? Yes. You have to be prepared with these kinds of questions. You have to learn how to play with unit. That's why I am telling you, I have given you a lot of numericals. I have given you a lot of numericals in my numerical study material. I have shared with you. Please take a printout. Please take a printout. Please, I am requesting you. Please take a printout and practice a lot of questions. I have given you 50 questions from a chapter. I mean from thermodynamics, maybe 30 questions are there. Okay. Yeah, Arnab, it's fine. Good. This Kelvin, 7.2 Kelvin will be your delta T. Okay. Delta T means, delta E means Cv delta T. You need to calculate delta T. Cv how can calculate? In this way, rotational translation, Cv value is this, total Cv is this, total Cv delta T. It's done. Good. Okay, 46 questions from thermodynamics. I hope you have done this. Shivras, I hope you did this. Yes. Next question. Solve it. Next question. Okay guys, listen one thing. Okay, great. Solve this question. Okay, first of all guys listen. Whenever you are solving this question, first do this. Compare this result with the work done in the corresponding expansion of ideal gas. So first consider this is your ideal gas. First of all consider this is not this. PV equals to nRT. Okay. First of all consider this is your ideal gas and taking all these values, forget about A and B values. Okay, forget about A values. Taking this value for 1 mole gas, V1 is this, V2 is this, temperature is this. So considering ideal gas, calculate work done first. So calculate W for ideal gas. First do this. First calculate this value. Please first calculate this value so that you can easily compare the value for this gas. First calculate for W for ideal gas. Please calculate. Don't calculate for this non-ideal gas. Please calculate for ideal gas. You just need volume V1, V2, temperature is given, number of mole is given, R value you know already. Just do this. And so can you tell me which process you will be following? I mean which process, adiabatic or isothermal process you will be following? How can you understand that whether it is adiabatic or whether it is isothermal? Can you write down whether it will be adiabatic or whether it will be isothermal? Because nothing is written over here. Can you decide adiabatic or isothermal? Adiabatic or isothermal? Can you decide? Just calculate W for ideal. Don't calculate for that one. Okay, why you are taking too much time, guys? Please do respond. Please do respond. Madhusudhan. Okay. Isothermal. Okay, very good. Yes, this is for isothermal process because here it is written that at low temperature, that means temperature is fixed. At low temperature, you will be continuing this whole experiment. That means temperature will be low throughout the reaction. That means temperature is not changing. That's why isothermal. That's how you will be understanding iso. Okay, Akash got on answer 15.29 kilojoule. Let's see. Very good. Did you put negative sign? No, you didn't put negative sign. You didn't put negative sign. 15 point minus, where is minus, Akash? Because look at this here, V1 is less, V2 is more, I think. Yes, V1 is less, V2 is more. That means expansion is happening. Expansion means system is doing work. Expansion means system is doing work. System is doing what? That is negative. Where is negative here? Where is your negative? You will be doing same mistake. You will be doing same mistake. Be careful. Please be careful with the negative sign. 15.29 kilojoule. Okay, perfect. No issue. Minus. Good, Fulvani. Okay. Arnab, good. So remember one thing. In exam, the answer they may ask in joule or they may ask in kilojoule. Please write down this point. Write down this point. I know this point is very important because I did a lot of mistake regarding this point. In exam, they ask you to get your answer in joule or kilojoule. Please get your answer in proper method. So if they are asking to get your answer in joule, get in joule. Get your answer in kilojoule, get in kilojoule. Just look at this. What answer they are asking, whether joule or kilojoule. Don't put anything. Okay, perfect. So first one you have done. Now the concept is, if the gas is non-ideal and following this expression, not real gas, I don't know what kind of gas it is, but if this gas is following this expression, so this expression belongs to any kind of real gas, but it is non-ideal. In that case, okay, A value is also given. This A value is also given. So in that case, what will be the work done? What will be the work done? What will be the work done? So remember, in this case, what will be the work done? What will be the work done? Perfect? Yeah. Now the thing is, come back. Let me show you something. Let me show you something. Just wait for some time. I am showing you something. Yes, I got it. This was your irreversible formula में P1 put करना पड़ेगा. Is this irreversible? Is this irreversible? Let me check once. Is this irreversible? Yes or no? Let me check. Okay, this is irreversible. Calculate the work done. This expanding from this to this. Okay. Yeah. So Arnab, is it irreversible? Is it irreversible? So okay, if it is irreversible, then they will give you external pressure or final pressure. Here nothing is written, and also this is not given. That means this will be reversible. If it is irreversible, then how can you use this equation? If it is irreversible, how can you use this equation? So another important point that you are getting from here. If pressure is not given, P2 or P external, if these two are not given, then understand this process is reversible process. Okay, so look at this. In this question, it is not given whether it is reversible or not, but you are considering reversible. Why? Because P external is not given or P2 is not given. That means generally irreversible process. So in this kind of question you will be having in IIT JAM examination. Yes, Siddhant, all these are IIT JAM level questions. Okay, so look, that's why I am using this expression. Same I have to do in this case. So what I will be doing, because I don't know the expression, but you know, I have already tell you that for ideal gas, for reversible process, work done equals to minus integration of 1 to 2 PdV. From this expression, you are getting ideal gas expression, this minus nR2 ln V2 by V1 or minus nR2 ln P1 by P2. How? You are just calculating P for ideal gas and putting it over here and doing the integration in this way. And you are getting your expression. You will be doing same job for this. You will be doing same job for this. For this one. For this gas. How? Simply calculate P from here. Therefore P will be what? P will be RT by V minus A by V square. This will be the P value that you are getting from here, and then do the integration. How? In this way. Look at this. V1 to V2 PdV, calculating, putting P value, and after doing this integration you are getting this expression. Okay, forget about 2.303 or log, put it RT only, RT ln V2 by V1. You can write that. That means you can write in this way, equals to RT ln V2 by V1 plus A into A into 1 by V2 minus 1 by V1. And remember, this value is the value is this minus W. So what will be the real W? W will be equals to what? Negative sign here, negative sign here. Okay, W means it is minus W value. Okay, look at this. So actual equation is what? If I show you, it is minus P dV. And here W, they are taking W over here, minus W equals to this, so plus W will be like plus W will be this. So you don't need to do this one, do it. W will be what? Minus this, minus this. Understood? Write Y in the comment box. Understood? Write Y in the comment box. If you have confusion, ask me. Solve tough questions. You can easily solve easy questions in your examination. And in most of the cases, question generally comes from isothermal process. I am telling you, it's a trick. In most of the cases, question generally comes from isothermal process. So W will be equals to minus, not minus, W will be equals to minus RT ln V2 by V1 minus this. If you solve this integration. That's why I told you, remember this value. Remember this expression. You can easily solve any kind of, you can easily get any kind of expression. Now I hope you are getting that why I did a lot of derivation in thermodynamics chapter. You don't need all those derivations. Very less number of derivations you need, but those will be important. And using this, you can solve a lot of mathematics. And if you check previous year question papers, in most of the cases, this formula is used generally. Okay, so I hope you got this. So final answer will be this. If you put all those values, guys, remember, look at this, look at this, look at this, look at this. If you put all those values, this value, this value, this value, you will be getting this finally. Okay, so do it as your homework. Your final answer will be this. Your final answer will be this, 13.71 kilojoule per mole. Please do solve it. If you are not solving this at your home, I can't help you, please. My job is to give you and make you understand. Your job is to practice. So I will be sharing you in the thermodynamic. I have uploaded thermodynamic notes, like slides. All these slides I have uploaded. So I will be deleting that and I will be uploading all these slides with these numericals. Whatever you have solved. Okay. Once we finish this one. Perfect. P external नहीं दिया है समझा, but volume expansion is from V1 to V2. V2 means V to 100. Okay, that doesn't matter. Arnab, it doesn't matter. It doesn't matter. It doesn't matter. It doesn't matter. You are doing theoretical study. you are doing theoretical study, okay, study, it doesn't matter. They are not telling anything, they are not giving you p external, simply reversible process, fine, it doesn't matter, please accept that. I have accepted that, you have to accept that. I can't help you with this, okay, accept that. If it is not irreversible, whether it is like happening like 100 or 1000 times bigger volume, then also you have to consider reversible, you can't do anything, okay. Okay, one thing, okay, I am considering it is 100 times, okay, so theoretically it is possible, because your process should be slow. Sometimes I know that for reversible process it needs infinite time to complete, yes, infinite time to complete. So if the volume is 100 times bigger, then it will require infinite time. What do you mean that? Let it take, right? Let it take. Next question. Yes, how many questions we do have? We do have a lot of questions, right? I think I can't finish these chapters. Okay, this is the last question. Okay, this is the last question that we will be solving. This is the last question that we are solving. Other questions I'll be solving tomorrow morning. Okay, tomorrow morning, 11:30 to 12 p.m. 11:30 to 12 to until last 3 hours live session. Tomorrow morning I'll be solving other questions. Okay, this is the last question. And till that time, please do one thing, do solve the numericals from the study materials that I have provided as numerical 1 and numerical 2. Please do solve numericals from the study material, please. This is the reaction. Okay, then why you are here? Why you are here then? You are saying here that you don't like my study techniques because you don't know. Okay, you don't like, then leave. You guys are just coming and like making negative comments to all of you, and you become happy. Don't come, just leave. I didn't tell you to ask or to join over here, right? If you are coming here to tell me this thing, you are welcome, but that won't affect me. Chemical kinetics. Okay, yeah, chemical kinetics. I am editing one video I have uploaded, and other videos I am uploading one by one. Okay, so should I do this, or you will be doing this? I think this question is not too much interesting questions, but yeah, as you have to calculate W, Q, delta E, delta H, so it will be interesting, right? It will be interesting. Should I do it, or you will be trying? Okay, my English is not understandable, okay, then go for Americans. Okay, I can't say English. I am very weak in English. I can't say English. I'm very like poor guy in English. Okay, so I can't help you, please. I'm sorry. I can't help you. I can't, like, my English is not good. Yeah, that's okay. And why I am making this class is in English. I don't need to explain you, right? The thing is, here both Hindi and English batch students are there. So if I make video in Hindi, English batch student, that means South India students, won't understand anything. That is the reason why I am making video in English. But you don't know anything. You are coming here to like demotivate me, but I won't do that. I won't let this happen with me. Okay. So please don't try this. Leave it, leave the class and enjoy somewhere else, please. Don't spread negativity. If you can't spread positivity, don't come. Live your life, enjoy your life. Because a lot of students are there who are doing hard work, okay? A lot of students are there, they are doing hard work day and night. If you are not understanding, if other students are watching this video, then they are understanding, right? They are not like looking at my face. I am not good. I am not that much good looking. Okay? So they are not looking at my face and just doing their job. They are here because they are doing their job. They are getting some help. That's why they are here. So don't, whatever you are liking, go there. No, I am not asking you to join, right? You joined and you were saying anything, I don't like you, it will not affect me, right? So just get lost. Okay, so forget about that. It is just wastage of time. Come back. Come back. Even I am comfortable in Hindi, but I have to like think about my all of students, because I can't at this moment, I can't make videos for Hindi and English for both the batches. It's impossible. In future, I'll be doing that, but at this moment it's not possible. That my students are the students, not my students. All the YouTube viewers already know that nobody in India like making videos in 2 languages to provide like students like. But sometimes like within 6 months I have completed the whole 3 years graduation, 3 years JAM syllabus. Nobody can do that, right? In different 2 languages basically. But I am trying, but okay, let it go. Forget about this. WQ delta E delta H for transformation of x1 and x2. Can I do that? Can I do that, or should you do that? You will be doing this. Can I do that, or you will be doing this? Okay. Yes, I am ignoring. Okay, a lot of students like ignore it. Okay, let it go. Let these things go. Okay, let this thing go. The thing is, you have to understand this. Can I solve it, or you will be solving this question? Tell me this one. Answer this. Please answer this. Can I solve it, or you will be solving this? This question is a little bit tough questions. Okay, look at this. Come here. Look at this solution. Okay, look at this solution. It is very small problem. Okay, it's just very small problem. Because you already know all these things. Just one thing that I want to do, that is about like give you a little hint, and the hint is present in the answer. The hint is present in the answer. Hint already given. Okay, hint already. Q equals to delta E is this same, and W will be this. Okay, so just do this. Look at this, just look at this. Q equals to delta E 27.2 kilojoule per mole. Okay, so if heat is given, like Q is given, where is it? Where is it? Yes, the heat of transition is given. Okay, so you are learning one important thing, that for solid transformation, this question is not important, but yeah, maybe this kind of thing you are facing in IIT JAM examination, you can face, right? Some you have already seen that some of the questions are coming from those topics which you don't know. Even nobody can solve those questions. That is the like question pattern in IIT JAM examination. So for solid transformation, delta E becomes delta H. These two becomes equal. And if delta E becomes delta H, so Q will be equals to delta E and delta H. And Q is given, so this value will be given. Similarly, you know, W equals to what? Minus P external dV. Yes, minus. Calculate W. Okay, calculate W equals to minus P external dV. Don't use this minus W. Don't use this expression. Use W equals to minus P external dV. Okay. Now W is P external is given 1 atmosphere. Convert 1 atmosphere to this Pascal. Delta V. These are also given V2 and V1 meter cube. So look at this. This volume. These two volumes are given in meter cube per mole. That means in SI. So volume is given in SI. That means pressure you have to take in SI as well. So pressure is given what? 1 atmosphere. Where is it? 1 atmosphere, right? Yes, temperature at 1 atmosphere. 1 atmosphere. So if you put 1 atmosphere means what? 1 atm means what? In SI, 1.013 into 10 to the power 5 Pascal, or you know, Newton per meter square. Just put it over here. Just put it over here. Okay, simple. Just put it over here. Understood? Q equals to delta E, then W should become 0 according to first law. Not at all. That is true. Whatever Arnab you are telling, okay, whatever Arnab you are telling, for solid transformation, I am not talking about only first law like things. For solid transformation, delta E becomes delta H, okay, and delta E becomes delta H, okay. Solid transformation, because whenever one solid is getting transferred to another solid, you don't generally care about like other like changing is like changes happens too much less. Pressure, like volume of solid changes too much less. Pressure of the system changes too much less. So too much less changing is happening. But whenever you are considering gases, suppose it is the cylinder. So for gases, volume changes is too much. Like in the last question we have seen 100 times volume is changing. But for solid, changes is not too much. Look at this, 5.309, 4.95. Yes, got it? So that is the reason why. Okay, so Q equals to delta E, then W should be delta 0 according to first law. Okay, you are talking in this way, right? Let's solve your problem. dQ equals to dE minus dW. Yeah. So if you are saying if Q equals to delta E, then these two will get cut and dW becomes 0. Work done becomes 0. Observation is good, but in this case, look at this. W equals to this volume change, right? External pressure volume change, and work done is not 0 because it will follow this expression. And why Q is becoming equal to delta H? Because it is solid transformation. So I cannot explain you in terms of like for this changing, because this is actually physical changes. Solid to another solid transformation. This is actually physical changes, not a chemical like changes. Because volume is not changing too much, pressure is not changing likely to be that. Okay, so that's why it is written a certain solid X exists in two solid modifications, X1 and X2. X2 is more stable at higher temperature, X1 is lower temperature. Okay, the transition temperature is 1 atmosphere. So as it is changing, look at this simple concept, or no, as it is changing, volume is there, this volume is there. So volume is changing means what? Some work done is happening, right? But the work done is too less. Look at this, 0.364 joule. Whenever volume is changing, volume will change when? Volume will change when system will do some work. Yes, volume change will happen when system will do some work. So if volume change is happening, system definitely do some work. And here temperature is not constant as well. x1 to x2, x2 is stable at higher temperature, x1 is stable at lower temperature. Okay, so transition temperature is this, it is given, pressure is 1 atmosphere, right? Simple thing. So because work done is happening, because volume is changing, but very less amount of volume is changing, that is why work done is too less amount of work. Look at the 0.364, and Q is equals to delta E because it is solid. For solid it is true. Okay, so this thing I can explain you from like CP/Cv. Can you remember this relation between CP/Cv, where I considered that for solid and liquid this like variation doesn't change too much. I told you already. For CP/Cv, I mean for whenever you are changing volume for Cp and Cv, okay, volume dependency, pressure dependency, for solid it is not changing too much. That's why Q becomes equals to delta H. Okay, that's why, that is the reason why. And also I can show you this one from another method. Let me show you. I told you this formula already, so that you can't say me, you can tell me that I didn't tell you. Look at this formula, Qp equals to delta H, Qb equals to delta E. I told you about these two formulas. I told you already, right? Can you correlate now? And this is because of solid. For solid, okay, solid and liquid, that behaves differently than the gas. Okay, and for solid it is, this becomes generally equal. But yeah, Qp becomes delta S, Qv becomes delta E. Now is that clear? Like I cannot make this thing like 100% clear for you, because in thermodynamics for solid and liquids we have to like we have to understand some like what should I say, assumption. Because I showed you already that for solid and liquid we ignore these terms. This kind of problem I have already shown you for solid and liquid, but in most of the cases we talk about gases. So this formula I have used. Now is it clear? Please tell me, is that clear? Maybe it's not 100% clear, but most of the thing will be cleared from this. Is that clear? Okay, so solid, remember these special examples. So now I am finishing this live session because it's already 11 PM, so I don't want to continue this one. So should I leave or should I give you some like problems? You will be taking the screenshot and you will be solving at your home. Which one? Should I leave or should I give you some assignments? Then I should leave. Homework. Okay, great. Take the screenshot. I am waiting for 10 seconds. Take the screenshot. 10 seconds. Four, 3, 2, 1, 0. Next one. Four, 3, 2, 1, 0. Next one. Four, 3, 2, 1, 0. Next one. Next one. Next one. Okay, forget about this. Till this. till this problem. Okay, so solve all this problem and make a PDF file, okay, by Adobe Scan. I am giving you the application, or Office Lens, or like Cam Scanner. So this kind of application, through these kind of applications, you will be making your PDF file and then sending it to the WhatsApp group. Okay. Yes, Akash, I have given to you. You are replying late. Okay. So yeah, we are done. So good night, guys. We'll be meeting tomorrow morning soon by taking all these solutions. And if you've done all these solutions rightly, I'll be moving forward easily after showing you the solutions. Okay. So good night, bye bye, meet you tomorrow morning, and all the first law equations are done. Only thermochemistry problems I will be solving tomorrow morning, okay, and then we will be finishing the left one, like second law as well. Yeah, good night, bye bye, and from tomorrow I will be starting chemical equilibrium. That will take 3 days maximum. So I will be simultaneously like revising all those things and also finishing the chapter. And chemical equilibrium you have done in your 10+2, that I will be like repeating once again. Some topics I will be incorporating, and 70 to 80% things I will be repeating. 70 to 80% things I will be repeating, like full ionic equilibrium I will be repeating. There is nothing extra. Okay, like more than like 70 to 80% will be repeating and 30% will be extra. You just need to understand some formula and apply it, like acidity, basicity, buffer solution, pH, POH, those kinds of things. Okay, good night, bye bye, meet you soon tomorrow morning 11:30 to 12 p.m. 12 a.m. I'll be meeting. Bye bye, good night.